All right, here we go. All right, starting with a review problem from last semester. It says a man who is 5 feet 9 inches tall casts a shadow 8 feet 6 inches. Assuming that the man is standing perpendicular to the ground, what is the angle of elevation from the end of the shadow to the top of the man's head to the nearest tenth of a degree? Okay, so before we solve this one, I want you to in this space right in here, draw me a picture of what you think is going on in this problem. Okay, see if you can draw a little illustration or a little diagram that kind of shows what's going on in this problem. So I'll give you about 2-3 minutes. Now I'm not a great artist, so I'm just going to draw a stick figure. So here's my guy right here. Now he is 5 feet 9 inches tall. So I got to decide, do I want to put 5 feet 9 inches? Do I want to change it to feet? Do I want to change it to inches? The inches would keep whole numbers. If you go to feet, you're going to be dealing with decimal. Because 5 feet 9 inches is not quite 6 feet. It would be 5 point something. So if we go to straight inches, we could take this 5 feet 9 inches. This would be 60 inches for 5 feet plus 9 more inches, and you'd have 69 inches. So you should label this guy as 69 inches tall. Now his shadow is a little longer than that. His shadow is 8 feet 6 inches. 8 times 12 is 96 inches. Plus 6 more inches, that gives me 102 inches. So this would be down here, 102 inches. Now what geometric shape are we drawing here? A right triangle. Now how do I know it's a right triangle? What's the key word? Yeah, this key word right here lets me know it's a right triangle. So I'm going to put a box there to show that it's a right triangle. And I'm going to connect the end of the shadow to the top of his head. Now it's asking us for the angle of elevation. Would that be the angle by his head or the angle by the ground? The ground, because the angle from the ground goes up, doesn't it? That's an angle of elevation. The angle from his head would be going down. So we want this angle that's going up, so this is the x that we want to solve for. Okay, so you might remember first semester we did some shadow problems. We actually used shadows to find the height of a tree and the flagpole and stuff like that. Those were similar triangle problems. Those used a proportion. Is that what we're going to do here? No, we're not going to be using proportions here. What do you think we're going to need to use here to solve for that x? What do you think? SOHCAHTOA. Why SOHCAHTOA? Why not lob sines or lob cosines? It's easier? I don't know if it's easier, but it is right that you have to use SOHCAHTOA. You can't use lob sines or lob cosines. Why does SOHCAHTOA work on this problem? Because it's a right triangle. Anytime you see a 90-degree angle, that's when you have to use SOHCAHTOA. If it's not a right triangle, then you use lob sines or lob cosines. So my explanation first is use SOHCAHTOA to find the angle. Now we should get a little more specific into SOHCAHTOA, because we may not know what SOHCAHTOA, some of you may forgot what it means or what letters mean what numbers and words and whatever. So let's get a little more in depth. Besides just using SOHCAHTOA, what part of SOHCAHTOA do I need?
Tan.
Okay, why tan? Okay, because this is the angle I'm looking for, right? What side is this 69 inches? That's the opposite side. What side is this 102 inches? Adjacent. You do not need the hypotenuse, and they didn't give you the hypotenuse. So you do need the opposite, the adjacent one, so that is going to be the TOA. So down here I'm going to put use tangent, because opposite over adjacent equals tan. And I'm going to put that there. Now one more thing I want to add to the first one. Use SOHCAHTOA to find the angle because, and I'm going to put a B/C, because it's a right triangle. Okay, we need to only use SOHCAHTOA because of the fact that it's a right triangle. Otherwise, we would be using law of sines and law of cosines. So now, if you have this explanation on your paper, when you get one of these on the test, you can kind of see what step-by-step we used, and maybe it will help you solve it on the test. Now, is it just tangent? So I'm going to put tangent equals 69 over 102?
Nope.
No, there's a little bit more in depth I need to get. What do I need to use? What kind of tangent? What do we call that?
Inverse.
Inverse tangents. Yeah, we got to use inverse tan, and in parentheses I'm going to put tan -1 because B/C, because we need an angle. Okay, so that's going to be what we're going to use. I think now we have enough information to go to the solution. I think now we can just simply write tan -1 and 69 is our opposite, 102 is our adjacent, and we can plug that into our calculator and we can get a solution. Okay, so let's look at if you have a calculator you can use it, but you can look at mine. Here's the calculator. I'm going to put 69 divided by 102. In this calculator I've got to divide them first. In those other calculators, like the ones that I gave you to use, you can just put the -1 tan first, or tan -1. So I'm going to divide these first, and then I'm going to hit the inverse and see how the tangent now becomes a -1 right here. So the tan -1, we're going to hit that button, 34.07. So what does that round to? 34.1 degrees. So that was going to be number one solution there, or letter A if we were doing A, B, C, D. Now I do want to show you one other thing really quick. If you had used feet instead of inches, if I had used feet, 5 feet 9 inches, you need to be able to know what decimal that is. 5 feet 9 inches. Is that 5.9? Which a lot of you will put down. Not 5.9 because it's not 9/10. There's not 10 inches in a foot. It's 9 out of what? 12, which would be what? 5.75. Because 9/12 would reduce to 3/4, which is 0.75. So that'd be 5.75. 8 feet 6 inches would be 8.5 because 6 inches is half a foot, 6 out of 12. And if I was to put that in my calculator, 5.75 divided by 8.5, and I still did my inverse and my tan, exact same answer with the exact same numbers because we used the same number. We just converted it to a different unit. So it's giving us the exact same answer for a degree, 34.1. All right, there is our review problem. Hopefully that reminded you a little of SOHCAHTOA and the inverse functions and stuff like that. Let's go to the first one for today. Okay, distances on the coordinate plane. So that's kind of what this whole unit's about. This whole unit's about distances on a graph. Now, when I give you a graph before, earlier first semester, and I wanted you to find the length from A to B, I told you just simply draw a right triangle. You count 1, 2, 3, 4, 5, 6, 7. This is going to be 7. You count 1, 2, 3, 4, 5, 6, 7. This is also a 7. 7 squared plus 7 squared equals C squared, and you can find out how long C is. Okay, that works every time. So if you get a graph and you got 2 points on a graph like this one right here, I could make my right triangle and I could solve it. Don't think that that doesn't ever work, because that will always work on a graph. So if you make a right triangle, we know Pythagorean theorem works. The question comes is, what if you don't have a graph and you just have 2 points? So let's find the distance between this point and this point. Then you might draw a graph, make the dots, and draw your right triangle and all that stuff, but it could take you a lot of time. There's a shorter way that we could do that using these x's and y's that you see on this little diagram here. This is our Pythagorean theorem. let me switch it around a little bit and put c squared equals a squared plus b squared. That's still the Pythagorean theorem? Okay, now I want to get c by itself. So I need to get rid of the squared. Square root it. Square root both sides. So I'm going to get c equals, now you got to think back to your algebra 2 days. It's not a plus b. A plus b times a plus b is not a squared plus b squared. There's a middle term in there that with the FOIL, right? So this is actually just going to stay. It's not even going to change. You can't really do anything with that. You just leave it. It's the square root of a squared plus b squared. So that's what c is going to equal. Now, here's letter A down here. You see this A? To get A, I subtracted my two x numbers. To get from one side to the other on the horizontal, I subtracted my two x numbers. So I'm going to take out the A. I'm going to put c equals, and I'm going to take out the A, and I'm going to put x2 minus x1 squared, because that's how I get A. I can get A simply by subtracting my two x numbers. So if I subtract the two x's, that's going to give me this bottom part of my triangle. When you make a triangle, if you subtract the two x's, you get your little A term that's across. The B term is when you subtract the two y numbers. So plus, and I'm going to do y2 minus y1, and that's going to be my B term. This is my A term. So do you see how I took the Pythagorean theorem and I made a little formula that uses x's and y's? This is called the distance formula. x2 minus x1 squared plus y2 minus y1 squared. They use d equals because that's for distance on a coordinate plane. So if you get this point and this point is not on a graph, you can simply plug it in and that will give you your little triangle, and you can just do it without having to draw a picture. So it's going to save you a lot of time if you know this formula right here. Now, let's get to today's examples. I was just showing you how they came up with the distance formula, how they use Pythagorean theorem to do it. Now, on this one, it's asking us, is JK congruent to LK? Is this side congruent to this side? So, first step, we're going to use right triangle and Pythagorean theorem. To find lengths. Okay, so we're going to use right triangles and we're going to use the Pythagorean theorem to find the two lengths. And then we're going to compare them. So that's what we're looking at here. So let's, in red, I'm going to draw a right triangle from J up to K. So from J to K, I went up 1, 2, 3, 4, 5, 6, 7, over 1, 2, 3, 4. So I got a 4 and I got a 7. So JK would be 4 squared plus 7 squared equals C squared. Since I have a picture, I'm going to draw my right triangle. I'm going to put a box right there. Draw my right triangle and do A squared plus B squared will equal my C squared, which is my JK. So that's going to be 16 plus 49 equals C squared. 65 equals C squared. We'll square root it. C is going to be 8.1. 8.1. So that's this one right here, 8.1. All right. So the first side, JK, is 8.1. Now, let's go to the second one here, LK. So to get from L to K, I go up 1, 2, 3, 4, 5, 6, 7, over 1, 2, 3, 4. It's a right triangle. We got 4, we got 7. What do we notice? It's the same right triangle. So if I was to put LK over on this side, I could just put an arrow down here because it's going to be the same number. They're going to be 8.1. So are those two congruent? The answer is yes. Justify your answer is just show your work here. Show how you did it. Show how you showed that they were both 8.1. So they both have to be congruent. Okay, now the next problem is actually not on your paper. I messed up and forgot to put a problem in between here. So you're going to have to turn it to the back and use this bottom part. Okay, there's some opening at the very bottom. It's a short problem that to write. It's this one right here. You're going to turn it to the back side. You're going to turn it to the back side. And there's some room at the bottom that you're going to put in the next problem. Okay, you're going to turn it to the back side, and you're going to, it's just a short writing. So you're going to find the perimeter of the triangle with the following coordinates, and then write the 3 coordinates down. Real quick, I'll give you a second to write real quick. All right, so if you get a problem like this on a test or quiz or homework assignment, and you see 3 coordinates, A, B, C, and you want to find the perimeter, and you know it's a triangle, what is your first thought? What are you thinking that you want to do to plan this one out? You think Pythagorean theorem with 3 points, it would work if it's a right triangle. We don't know if it's a right triangle, so you probably would graph it. You'd probably graph the 3 points. So your plan would normally be to graph the 3 points and use right triangles and Pythagorean theorem. To find perimeter. And you know what? That's probably what I would do too for the most part. But since I know the distance formula and I just showed it to you, I'm going to use that because I think it's going to be shorter for us. And I want to show you it so that you can see that how nice it works, that we don't have to always draw a picture. We could actually use 2 points, and instead of seeing them on the graph, we could actually just use the formula and see exactly how long those 2 are. So what I'm going to say here is use distance formula and we're going to put in parentheses d equals the big square root x2 minus x1 squared y2 minus y1 squared. Okay, and that's in parentheses. So we're going to use a distance formula to find length of each side. So both of these will actually work. This side will work, this one will work. This one's going to take us less time because we're just going to be plugging them into the formula and then adding them up and getting our perimeter. So, to find the length of each side and add. Because you want to add them together to get your perimeter. So what I need to do is find which 3 sides I'm looking for. So if I make A, B, and C, from A to B is one side, right? So I need to find the length of AB. Okay, what's another side of the triangle I need to look for? B to C. From B to C would be another side. So I'm going to leave some space for my work, and then I'm going to put BC. And then the last side that I need to look for is from A to C. Because A is going to go to B and A is going to go to C. So A to C would be my last side. Okay, let's look at this formula and see what we have here. So I'm going to put the big square root. Okay, now for me, x2 minus x1, I usually start at the second point and come back to the first point. That's just me. I just do it that way. You don't have to do it that way. You could start with the 1 and do 1 minus negative 3. But if you start at 1, then guess where you need to start with your y numbers? You need to start at this 2 right here. So you could do 2 minus negative 2. I wouldn't do that. I would start with negative 3 and come back to the 1. So I'm going to do negative 3 minus 1 squared. Okay, so that would be my x2 minus my x1. So those are my 2 x numbers. That's going to give me the horizontal value for my little right triangle. That's my A term. Now my B term is my 2 y values. So negative 2 minus 2. So my negative 2 minus 2 squared. So this is like my x2 minus my x1 This is like y2 minus the y1. That's what that is. Now in your head, -3 minus 1. -4. Square it. 16. Positive 16, right? So put 16 plus -2 minus 2. -4. Square it. 16 again. So you're going to get the square root of 32. And if you look at a calculator, you do 32 square root 5.7, because you're going to round that 5 up to or the 6 is going to round up to a 7. So 5.7 is the length of AB. I just want to show you something. You don't have to write this on your paper. I just want you to look at this. I want to show you if I graphed it, and I did the first point at 1, 2. That was point A. And the second point was -3, -2. That was point B. And if I graphed that line right there, if I made my little right triangle, let's say I was trying to find that length, I would have to go over 4, and I would go up 4. Over 4 and up 4. A, B. 4 squared plus 4 squared, isn't that going to be 16 and 16? Same thing. So you're really using that, but you're putting in the numbers instead of having to draw the graph. So that's all you're doing. So there's the first side. Let's do BC, big square root. So I'm going to start at C. My x is 1, and my other x for B is -3. So 1 minus -3. You might get some double negatives here. You should know from Algebra 1 what a double negative turns to. Positive. So that's going to actually be 1 plus 3. 1 plus +3. Now let's look at the two y numbers. -5 is my y2. -2 is my y1. So -5 minus the -2. -5 minus -2. Got to be careful because you might get some double negatives. What's -1 or 1 plus 3 actually? 4. So 4 squared again is 16. -5 minus -2. Make those pluses. -5 plus +2. -3 squared. +9. And that's going to give you the square root of 25, which is 5. So there's my second length. So far I've got two lengths. Whoa. Okay, so there's our two lengths. We got to find A to C. A to C. So we're going to do the C first. So we're going to do 1 minus the 1. That's interesting. 1 minus 1 squared. And the y value is -5 minus a 2. So -5 minus 2 squared. Well, what is 1 minus 1?
0.
0. What's 0 squared?
0.
Do we need to even write it? No, because 0 plus anything is still that number. So we don't even need the 0. What's -5 minus 2? Square it? 49. And then we want the square root again, so we're back to 7. So to get the perimeter, you're going to add them up. 5.7 plus 5 plus 7. And you get 17.7 units. So that's your perimeter. That's how the distance formula can work. So tonight, you're going to have 6 problems where it's just going to give you 2 points. And instead of graphing them, you could just plug them into the square root and get your answer. Okay, so just do those quick square roots and then you got your answer. I did 3 of them already and that didn't take very long. All right, moving on to this is our next one, the pond problem. So yeah, back to the other side. A rancher wants to control animals from accessing a pond on his property. So they must be getting into his pond and making havoc in there, messing it up. So he builds a fence around the pond so they can't get in. Find the length of the fence he needs to build the entire thing. Not just one side. How much fencing does he need to build the whole thing? 1 unit is 10 feet. Okay, so what would we do first? What would be the first thing, if you look at that picture, first thing you would do? Is there any two sides that you could find right away?
Well, yeah, B and.
Yeah, wouldn't you want to find the horizontal and the vertical just by counting? Couldn't you just count over and count down?
Yeah.
So that would be my first thing in the explanation. I would count horizontal and vertical sides. You can put it however you want. These are your notes. You can use them on the test. I'm just trying to help you so you have more information when you do use them on a test. Okay, so to count across, you would get 10. So if you count, you can see there's going to be 10 going across. Now you could even look at that. X2 is 14. X1 is 4. What's 14 minus 4? 10. There it was. You can do the same thing for Y here. 13 minus 2 is 11. That's got to be 11. So and if you count it, there's 11 there when you count it. So there's two sides already done. What would be the next thing you might do? You need to find these last two sides. Not a perfect square, a right triangle. We want to make a right triangle so that we can find the length of those other sides. So down here, make right triangles on other two sides and use Pythagorean theorem. If I just put Pythag, well, you know what that is?
Yeah.
Pythag theorem? Okay. So Pythagorean theorem is what you'd use after you make the right triangle. So let's do that next. So I'm going to do that in red so you can see it a little better. I'm going to go over 1, 2, 3, and down 1, 2, 3, 4, 5, 6, 7, 8, 9. So over 3 and down 9. Okay, that's a right triangle. I can put a box right there. So if I want to find the length of AB from A to B, that side, A to B, I would need to do 3 squared plus 9 squared. You don't have to do distance formula when you have a picture because you can just make your right triangle and just count them. So 3 squared plus 9 squared, so that's going to be 9 plus 81, which is 90. So square root both sides. C is going to equal 9.5. Okay, so that's AB. That's this side right here. The bottom piece, we want to make a right triangle down there as well. So that would be down 2 and over 13. Down 2 and 13 over. So we got an A is 2 and B is 13, and we want to find C. We know C is bigger than what? Bigger than 13. Got to be the biggest side, and the biggest leg is 13, so it's got to be bigger than that. So we're going to use 2 squared plus 13 squared. So to get AD, 2 squared plus 13 squared equals C squared. 4 plus 169 is 173. And you square root both sides. You're going to get 13.2. So this amount down here is 13.2. Okay, down here, explanation, we want to add sides for perimeter. Add the sides for the perimeter. So perimeter equals 10 plus 11 plus 9.5 plus 13.2. You add all this together and you get 43.7. So 43.7 units. 43.7 feet he needs. Now, what's the last thing we have to do? We got to multiply by 10 because BC, because 1 unit equals 10 feet. So we're going to multiply this by 10, and he's going to get 437 feet of fence. Now, he'll probably want to get a little bit more than that because you always make a few mistakes here and there. So you never want to buy the exact amount.
Like,
So you probably want to buy 440 or 450 feet just to have that extra, just in case. Just in case. Okay, the last two are not too bad. They're pretty short ones. So I'll show you those. They're on the back side. And the next one, it says it's got two ships, ships A and ship B. Now ship B needs to be resupplied. Ship A is coming to meet ship B so that it can give them the supplies. They're going to meet at a point halfway between their locations. So what you should do is grab your ID card or your folder or something. You don't need a ruler for this. Just make a straight line from the two ships. Just draw a straight line connecting the two ships. You want to get ship A and ship B. We want to find out if they draw a straight line between the two. Straight line between the two, that's the shortest distance they would have to travel. So we want them to go straight to each other and find that exact halfway point. Okay, now I gave you a midpoint formula first semester. You might remember. What is it? Close. Plus. Plus, because you got to add them and divide by 2. You need to get the average of the 2 points. So we're going to put under explanation, use midpoint formula. And you're going to want to make sure you have this down because there's 6 problems on tonight that you're going to need this easy little formula. x1 plus x2 over 2, y1 plus y2 over 2. You're adding the 2 x's and dividing by 2. You're adding the 2 y's and dividing by 2. So that would be our midpoint formula. So let's find that first. So if I'm using that formula, my x1 is negative 9. If I'm working across my graph. Negative 9 and a positive 7. So negative 9 plus 7 divided by 2. The y's are negative 1 is the first y. 5 is the second y. Negative 1 plus 5 over 2. What is negative 9 plus 7? Negative 2 over 2. And then what is negative 1 plus 5? Positive 4 over 2. So what is the midpoint if you end up dividing those numbers by 2? Negative 1, comma 2. Check that. Look at your graph. Find that point. See if that's on the line. If it is, it's halfway. Is it on our line? You go over negative 1 and up 2. There it is right there. That is the halfway point. That means that this piece is equal to that piece. That's your midpoint on that graph. That would be where they would meet. The last part of the equation says that how far will each ship have to travel. That's this last part right here. So to find that, we're going to use right triangle and Pythagorean theorem to find distance. Now we could have used the distance formula. I've got the points here. I've got all 3 points now that I found the midpoint. So I could use the distance formula. But when I have a picture, I think using the Pythagorean theorem is a lot easier. From ship B, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and up 1, 2, 3 to get to the midpoint. 8 and 3. That's the distance that ship B has to travel to get to the midpoint. Okay, now, should we check ship A just to make sure it's a midpoint? I would say, yeah, we probably should. Over 1, 2, 3, 4, 5, 6, 7, 8. Down 1, 2, 3, and it is 8 and 3. So they are the exact same distance. So let's get our distance. It would be 3 squared plus 8 squared equals c squared. That's 9 plus 64 equals c squared. So 73 equals c squared. Square root both sides. And let's see what square root of 73 is. 73 square root, 8.54. So you were close. 8.5 is closer. So we're going to say 8.5 is the distance they would have to travel. 8.5 units. But what does this one grid unit say? Yeah, one grid is 20 miles. So the last thing we got to do is multiply by 20. Because 1 unit equals 20 miles. So take 8.5 times it by 20 and get 170 miles they have to travel. And it's important that they figured that out, because what if ship B doesn't have enough fuel to get there or something? So they're going to know, ship A has to know, and maybe they have to go farther or something. So that's the midpoint formula. That's finding the distance to the midpoint. All that stuff that you might need tonight. So there are 6 problems where you're just going to plug it into this midpoint formula and you're done. So those shouldn't take you more than 3 minutes. All right, last one. We good here? No? Okay, it'll be on the website if you need it later. But I gotta get this last one in. Okay, prove that triangle ACM is congruent to BCM. Kind of a review, but kind of a new one. This kind of puts 2 things that we've done together, or thing that we did in the past and the thing that we're doing right now. Put them together. Because we learned how to prove that triangles were congruent last semester. There were 5 ways. SSS, SS, or SAS, ASA, AAS, and there's one last one. HL, right? The shorter one, the HL. Now the CPCTC, that's for after you prove they're congruent. So HL is the 5th one. So we have 5 ways. Which way might we choose to prove that these 2 are congruent? If I choose side angle side, if I do SAS, which you guys seem to love SAS, if I was to do SAS, I would know I have a 90-degree angle, so I would need these 2 legs, and I'd have to show that they're congruent to those 2 legs. Or I'd have to use my inverse trig to find this angle and then find those 2 sides on both triangles, which is possible. You could easily do that and easily prove that they're congruent, but it's the longer way. If you did SSS, you'd have to find all 3 sides on the one, and you'd have to find all 3 sides on the other and make sure they match. Another longer way. There's a shorter one. HL. Now what does HL only work on? Right triangles. And if you notice, what about this CM right here? CM is a leg, and it's in both triangles. So do I need to even measure it? No, reflexive property says it's already congruent to itself. So I can automatically make one tick mark here and put this leg is congruent to that leg. I don't even need to worry about that leg. So my plan is to use HL theorem because it's a right triangle. Okay, so that would be my first thing. It's a right triangle, I'm going to use HL. Now I'm going to put CM is a common side and congruent to itself. So I already got the L. The L's done. So I'm going to even put under here, I'm going to put that it's a leg. It's an L. So the only thing I need to do is find the length of both of the hypotenuses. So find length of both hypotenuses. All right, so let's use the right triangle to do it. Whoops, that again. Okay, so on this from A up to C, I would go up 2 over 1, 2, 3, 4, 5, 6. Up 2 and over 6. So for AC, 2 squared plus 6 squared equals c squared. That will give me my AC. This is my little c right there. 4 plus 36 is 40. Square root both sides. Square root of 40 is 6.3. So this one is 6.3. So this side is 6.3 right here. To get CB, I go over 2 and I go down 1, 2, 3, 4, 5, 6. What does that tell me about the two triangles? They're both 2 6s, right? So this is also going to be for CB, and they're both 6.3. So therefore, they are congruent by HL theorem. So they're both, this would be an H, this would be an H, and you would have the HL theorem showing that they're both congruent.